Sure we understand what lowest common means. Lowest common means that we want the denominators to be the same. So I want both of these two denominators, whether it's monomials, right, or binomials, or a bunch of binomials. Ooh, look exciting. We're going to get some factored form, and then we get more. Okay, so let's do the monomial first. I want these two denominators to be the same. We're used to doing the numbers. So the numbers are 6 and 8. What's the lowest common denominator between a 6 and an 8?
24.
24. Okay, so we're going to get 24. So I'm going to do this. So I'm going to write down equals, and I'm just going to set it up here. So look, I put question marks there because I just want to focus on the denominators for a second. So I know that the number would be 24. Right, so I need them both to be 24. So this one I would multiply this one by 4, right? Top and bottom. Okay, I might do more, so hang on. And this one by 3, right? So 3, and then I might do some more. All right, so 24. What else do I need? I need the m's. So it's monomial, so it's 6 times m times the n. How many m's do I need? If I have 1 here and 2 here, what's the lowest number of m's I can have that both of them would have the same? Yes?
1 on the left side.
1 on the left side. That's the lowest number of m's, but I want them both to be the same. Can this one ever become 1? No, it'd have to cancel. So I need this one to become 2. So I need an m here to make this one m squared, and then they match. And what do I want both of them to look like? M squared. So it's the lowest number that both of them can become. Right? I know this one's only got an m, but I can't make this one be squared, right? It already is squared. There's 2. Does that make sense? So between an m and an m squared, you have to bring this one up to m squared by multiplying it by m. All right? All right, so now we tried that. Try it again. How about the n's? If I have 4 here and 7 here, what's the lowest number that both of them have to be? Yes? 7. Does that make sense? So you can't make this one be less. I need how many more here? 3. 3 more, and they would both be n to the 7. And then you would do the top part, right, and stuff like that. So this one only needed the 3 then, right? So times 3, and everything else was good on that one. So this side, I would be 4m n cubed times question mark. So on the top here, does that make sense? So do the numbers first. It's a monomial times the m times the n. So this would end up being 4m n cubed times question mark, whatever that is. You still take the sign here, so you go plus, right? And then you'd go 3 times whatever that question mark is. Does that make sense? 3 times whatever's there. I didn't fill in the question mark. I just want to practice lowest common. That makes sense? So you're trying to make them become whatever number you can, the lowest number you can make it, but you can't take away anything, right? Okay, let's try it again with monomials and binomials. All right, so here, I'm going to do my equal sign under. Again, I'm just using a ruler, just trying to keep my notes neat so you guys can read it. And we have, one sec, so we've got equals. We're going to do the same, lowest common. Okay? And we've got 3x and the 4. Okay, so do the monomials separately. So the 3x and a 4, right? Between the 3 and the 4, what's the lowest number that both of them can become, can be changed to? 12. 12. Right, so 12 on that one. Okay, so then right away this means that this one has to be multiplied by 4, right? 4, and this one would be multiplied by 3. You can just write it around it. You don't even have to do the brackets and stuff like that. Okay, yes?
Does it have to be multiplied by 3x?
Yes, so how many x's? So I have the 4 for the monomial. This one here has an x. This one doesn't. So this one needs an extra x, right? So we want this one to have an extra x to it, right? So multiply this one by 3x, and this one by 4. And whatever you do to the bottom, you do to the top, right? So 3x, or I'm going to write on this side. Too squishy over here. Okay, so 3x, right? So we want how many x's? This one has 1, this one needs 1, so I know it's going to be on the bottom. I should have a 12x for both of them. Do I have a 12x? 12x, 12x. Good. Okay, so now both the monomials are done. Now, the binomials. I actually find the binomials a little easier. I have 2 of that bracket, 2 of x minus 5s. I have 1 x minus 5 here. How many do I need for both of them to be the same? For both of them to be the same. Yeah.
Don't you need one more on the right?
Yes, I need 1 more on the right. Isn't that nice? So it's just a matching game. So minus 5. Total, both of them should be sitting on 2 of them, right? They should both match to 2. So I set it up like this when I'm doing it. So I'm thinking of it here, and I'm putting it here, and then I'm going to be able to multiply it all out. Fine. Good? All right. Then I go, uh-oh, this one has an x plus 2. This one does not. So then this one needs the x plus 2. So that one needs an x plus 2. This one doesn't. It already has it. And both of them should have 1 x plus 2. So now look, are all the denominators the same? This is 1, 4, so 12x, 1 of these, 2 of those. Look at this one, this denominator here. There's a 4, 3x, so 12x. I have 2 of these guys and 1 of those. So both of them are matching. So then when I set up my next line, I already know that this one's going to be multiplied by 4 x plus 2 times whatever that question mark is, right? So whatever's there. I take whatever the sign is in the middle. If it's plus or minus, I put whatever it is. And then this one will be multiplied by 3x, x minus 5 times whatever's I put on the top there. And then you have to do, and remember at the beginning of the chapter I did the expanding, and I said you have to be able to do 2 brackets and a number. That's why we practiced it, because here you got to be able to expand, collect like terms. Right, so you'd expand, collect like terms, and you always keep, look how gorgeous that factored denominator is. Beautiful. Leave it factored. Do not expand that. That would be a waste of time, plus it's beautiful that way. Yes? Yes. This way? That. This way. Okay. I forgot to do the restrictions again. Does it matter what order I do the restrictions in? No. Right, so you can do it later. Right? I always put it as step 2 just to remind yourself, but actually you can do it after. With the canceling, though, be careful, because if you cancel it, you still have to write it, right? So that's why I always say it's step 2. In this case, I'm not canceling anything, so it didn't matter. Try to do it right away. If you forget, it's not wrong. You're just going to make sure you do restrictions at the end. Okay, so it doesn't matter actually what order, as long as you don't forget any of them, right? You don't want to dump any of the ones that you cancel. So I'm going to do my restrictions. Do you want to try to do it without writing the rough? Are we at that point yet? What would be the restriction for this guy? For 12x. Yep, 0, right? So x cannot equal 0. How about this one? We good with this one? Solve it. 5. And this one? -2, yeah. So if you're there, then you can go straight there. You don't have to show me any of that rough work. Okay, if you still like the rough work, do it on the side. There we go. So I put step 2 as the restriction, but honestly, you can do it anytime. Just you can't dump any of the canceling ones, because once you do that, then you're going to be losing part of your restriction. Okay? This one, what would my restriction for this one be? It's not done. I know that there's more steps here, so these guys would still have to finish the question because I gave question marks. What would the restriction for this one be? A monomial, not plus and minus. That was the question that was asked earlier, right? Monomial times and times. So this would be m cannot equal 0 and n cannot equal 0. They're factors, right? They're multiple of each other. So that was that question that we had earlier, right? With the monomials versus the plus and the minus. Okay, again, you can do that at the beginning or at the end. We'll do more. Questions with that so far?